appreciate the opportunity that Pat's given us to have a spotlight on the supplier perspective in this conference. It's much more common that we get speeches on launch providers and vehicle integrators, and less common where we discuss the supply base. Stellar Technology is a sensor manufacturer, as Wayne talked about in that wordy description of what we do. We've, for the past 30 years, have been a primary supplier to traditional NASA programs, and then we've been able to adapt in this environment to get to participate in the commercial space business. And it's an area we take a lot of pride in, working directly with the engineers associated with developing the rockets, developing stages and vehicles, and then watching them fly. We're involved in the rocket test stands. We're involved in proof of concept testing. We're involved in their fluid pressurization systems. We help with their launch complexes with facility sensors for tanking and detanking. And we're involved even sometimes in their environmental control and launch support systems. Sensors, that's not the topic for today, but sensors in general are how we listen to our hardware while we're developing prototypes. They're how we validate requirements for our certification processes. They're how we commit to launch on the day of launch, how we decide, do we have the right pressures, do we have the right temperatures, are we armed? As we move into more autonomous flight with uncrewed vehicles for cargo, they're involved in those autonomous flight maneuvers, and unmanned docking. And we're moving into an era of reusable launch vehicles. Those reusable launch vehicles, one day, similar to what the commercial aircraft industry is doing, will use total predictive maintenance, which will use a sensor to tell when it's time to replace a hydraulic strut on a reusable horizontal takeoff or horizontal landing vehicle, which will further extend its program life and reduce its operational cost. So that's background on Stellar. We're a division of Lord Corporation. Lord Corporation is a billion-dollar aerospace, defense, and industrial company. They have applications in adhesives that are structural, coatings for protection of lightning and electromagnetic effects. They have electromechanical actuation for real-time vibration control. They're a very dynamic company. We're privately held, and we've joined them in the last year and a half, and they've been a great addition for leveraging what we've already done and moving forward into a new era with them of growth. So this is a word cloud that I just want to start with. Those of us that have been involved with engineering vehicles, a lot of these terms are familiar. These are the terms that kind of guide our industry. These terms represent to us requirements that we can put in specifications that help us procure hardware. It's interesting, though, that despite our robust requirement flow down, a lot of times we still have vehicle incidents. I think yesterday there was a quote that we've had over 400 launches into space in the history of space travel, and we've had 22 failures. For those 22 failures, you have to imagine there were thousands of smaller failures, right? Prototypes that didn't pan out, designs that had moved into qualification that ended up not meeting spec and having to be redesigned, and then even integration issues. When you qualify each component individually and then you bring it together into a system, you have the additional challenge of system integration issues. So even with great requirements, we still have shortcomings. And as a supplier in this industry, we've learned that a lot of those lessons learned end up residing in the supplier's information base. And so what we kind of find right now is that as we commercialize space, we stand a little bit on the shoulders of all those that came before us. That those prices have come in the form of taxpayer dollars, in human life, and individual contributions. So the importance of maintaining that pedigree is important, and what we find right now is a trend in commercial space companies, especially, to what I call insource. There's a drive to control all specs of manufacturing and production. So the goal and vision would be raw materials come in the door and a finished rocket goes out the other end of the door, which is an amazing concept, agreed. We try and do that at the sensor level to buy as few things as possible. It gives us the perception of control over cost and schedule and the ability to change directions without having to influence an entire supply base. So the approach does have its merits. But I'm going to make a premise that the pedigree and lessons learned from previous generations of NASA and DoD programs resides within the historical space supply base. Their employees come and go, people move around in the industry, but there seems to be a culture in each of the individual suppliers, that the critical suppliers for this business, where we have people who were there 20 years ago. The people there before had experiences 20 years before that. We get a continuity of one product type and history across lots of launch failures, lots of rocket test stand incidents. So this is an important area. We have a lot of experience making a sensor work to an engineering specification in a lab. We have to get even more experience, though, when somebody brings us an application and wants us to fly it. For example, we get solenoid valves, a sensor in a solenoid valve, where the solenoid valve is going to open thousands of times in a short duration burn. And that's going to happen hundreds of times during the entire vehicle lifespan. We learn different things from applications like that we apply to future products. We help amortize equipment costs when our space sensors ship out the door to any of the individual companies that are in this industry. Our production doesn't stop. We have customers in the oil and gas and subsea exploration industry. We have customers in overland vehicles. We learn from those experiences, and they help our aerospace products be better. Conversely, our aerospace products help those other products be more reliable. As a company, we participate in what's called the National Rocket Test Group. It's an industry comprised of academia, industry, and government rocket test sites from all across the country. We're one of only 2 supplier companies that participates in that, and there's only 2 of us that don't have an actual rocket test stand. So it's funny to be a participating member of a rocket test group and not have a rocket test stand. But it's amazing the feedback we get when we share lessons learned about instrumentation, cabling. We would like to see more of these types of industry groups where you can share this information, and we'd like to see more suppliers involved with those, because like I said, our premise here is that there is so much information held in these individual companies that maybe doesn't get represented in this industry. So how do we balance the benefits that come from a supplier relationship with the perceived risks of having a supplier? So how do we balance component cost, schedule control, design autonomy with supplier design pedigree, lessons learned, and cross-industry knowledge? For us, that's come through a slide here that we'll show. So this is a lot of information, and I'll just try and briefly explain it. But in the green bars, that shows our total business volume relative to the commercial space industry. So in 2010, we were 80% NASA programs and only 14% commercial programs. Fast forward to today, we've had to evolve with the industry. In some ways, we didn't have a choice, but we got out ahead of it early and didn't suffer some of the consequences of those who waited. So as our business volume grew, we had to make a decision, though, because the pricing strategy for the commercial space industry was so drastically different than the traditional programs. So our cost per sensor, if you just look at our entire business volume and the number of units we shipped, you can see we've had almost a 5x reduction in the price per unit as we went through here. So it had to be a business decision for us to make that step, because sometime between 2010 and 2012, as we brought the price per unit down and the business volume went up, we actually shipped more units than we'd ever shipped and maybe earned less than we had under previous programs. So it was a decision to make that. Luckily, that investment that we made has led to a relationship with the commercial space business that means we've been able to help them achieve some of their cost objectives. The total growth indicates we've been able to be a successful partner for meeting schedule and keeping their projects on time. So what made this possible? There's 4 main things. We invested and bought into the plan. And had to take a leap of faith somewhat to do that because, as we said, as you drastically reduce the price, just like the vehicle integrators have to do, they have to make a decision. As we reduce the price, we actually reduce the total pie temporarily. Then we hope that the volume comes that'll make the cost of access to space less expensive. So we had to make an earlier investment than even they did to make that happen. We had to buy into the program. So we invested in commercial space. We also had them invest conversely in us. They gave us purchase orders. They carried us through that period. So one of the areas that helped us make the cost reduction possible was to really focus on requirement management. And we just had a great presentation on making sure we stay focused on systems engineering. What we've tried to do, though, for commercial space is adapt our involvement in system engineering to those features that are just absolutely necessary. Pulling down, avoiding, if we can, the full flow down of requirements for less critical or engineering information only applications. And then having increasing complexity in our systems engineering and the number of people and staff we have to keep on relative to the number of sensors. So there's a much greater ratio of number of sensors to number of people involved now than there was back on the traditional programs, where maybe we would have 5 people working the program full time and we would ship 10 sensors in the whole year. Now we're shipping thousands of sensors with not a drastic increase in the number of people. So the proliferation of requirement management consumes a lot of money in this industry, and that's been one way we've really been able to help. The biggest thing, though, I think, is we have strategic relationships with the commercial space companies. We go out and we sell solutions to problems, and then the orders follow. That's been the biggest thing. We've had commercial space companies have the opportunity to make sensors with the information we gave them and build their sensors in-house. They keep coming back to us because we come out to their rocket test sites. We'll get on a plane, we'll get in the car, we'll drive out and stand in the dirt and wind with them and find out what's happened. So that's one of our biggest areas. We find engineers are nomadic. They move from organization to organization, and we've been able, as they leave, it's often that we get calls that say, hey, I'm over here now, can you help us with sensors? So to sum up, because I'm out of time, going along with the theme, we think suppliers make a difference, and we would encourage this industry to continue to leverage strategic suppliers in the commercial space business to capture the investments of previous space generations and to utilize the supplier pedigree and lessons learned to reduce the cost and improve mission reliability. Thanks.
Thank you, Jason. Appreciate it very much.